Hey y'all! Today's lesson is the Pythagorean Theorem in 3D. Let me move this box. I guess I can just click on that. All right, so you have your notes, and we are going to go through these problems together. The Pythagorean Theorem in 3D, three-dimensional, is going to use, again, right triangles, but instead of it just being a flat triangle, it's going to be 3D. So I'm just reminding you the Pythagorean Theorem states that a squared plus b squared equals c squared. A and b are legs, and then c is the hypotenuse of a right triangle. And so we're going to work through these examples about the Pythagorean Theorem in three-dimensional. Number one, a box used for shipping narrow copper tubes measures 6 inches by 6 inches by 20 inches. So you have, you see your box. Oh, the shading is weird. I wonder if I turn the light on. It still kind of shades. Hang on, let me check let's see, brightness. Nope, that's not it. Exposure, I'll turn that off. Let me check. Okay, we'll see. Okay, maybe that's better. So it's a 6 by 6 by 20. So the 6 and 6 would be on the ends. That would be a square. And then the 20 inches, obviously, is going to be how long it is. I would always label your dimensions. And then what is the length of the longest tube that will fit in this box, given that the length in the tube must be a whole number of inches. So again, we're going to keep whole number, circle whole number, because that's what we're looking for. Now, if you were trying to fit something into this box, and if we were in class, I would bring a box and I would have you would demonstrate. But if you were going to try to fit something in this box, the longest tube that would fit would go from one corner to the opposite corner. And so if you see, this is the back corner to the front corner. And so connect those kind of like a thin copper tube. That's actually going to be the longest that an item or a shape could fit into a three-dimensional box, because it's going to go across the box. It's going from the back all the way to the front. It's not just laying flat, and it's not just going from one side to the other. It's actually going diagonal. And this is what makes the Pythagorean Theorem in 3D a little bit different. We cannot just do a squared, b squared, c squared, because I actually have it's crossing over 3 dimensions. So in this case, we are actually looking for something a little different. I'm going to use colors to show you. Hold on, I have to go over here to my colors. Let's see. I'm sorry, I forgot my colors. I'm going to show you where this distance comes from. So in order to find this tube, we need to find, whoops, my dashed line. Okay, I'm just going to connect it. All right, we got to find the red. We got to find the red in order to find the copper blue, because we're looking for triangles. So to find the red, I'm going to shade in this triangle that you see. And you can see that I have made another right triangle. Now for this, I know that this leg is 20 and this leg is 6. This is the hypotenuse, and so we can call that C. To find C, I would use 6 squared plus 20 squared equals C squared. And I would solve that for something. So 36 plus 400 equals C squared. So this would be 436 equals C squared. So C is the square root of 436. I'm just going to leave it right that, just leave it like that for a minute. Okay? Now, once I find C, now I'm going to use my pink. Once I find C, now I can use C and this leg to make that triangle. So I'm going to color that in pink. And I've kind of made like a triangle, kind of a slice of the box. Like if you were to slice the box, that would be the triangle. I know that C and this is a leg and this is 6 again. So I would use C and I would use 6 to find this height, which we can call slant height, or we can call h for different, or we can call L for length. But it's more than just a hypotenuse because it's going across the dimensions of the box. It's going from the back to the front. And then I would just do the Pythagorean theorem again with C, which is over here, 6, and I could find that. But I'm going to show you kind of how you can do it all in one step. To find C, I used 2 of the legs, 6 and 20. Do you see that? 2 of the legs. Then, in addition to using C, I need to use the other 6. So, to find this height, I'm going to use 6 squared plus 6 squared plus 20 squared. I'm going to use all 3 of them. We'll actually call this length, I'm sorry, because it's the length. What is the length? And again, I'm using all 3 numbers, and the reason I'm using all 3 is because to find the tube, I'm using 6 and C. And in order to find C, I used 6 and 20. So 20, 6, and 6 to find the length. And I'm going to use the Pythagorean theorem in 3-dimensional. And I'm definitely going to use my calculator to find, L. So I'm going to take the square root. L is about the square root of 472, and I'm typing it in my calculator, 21.7, but it says the length of the whole number of inches. The whole number of inches. So in order to find that, if I want to round, if I round it up to 22 inches, would a tube 22 inches fit into this box? And the answer is no, because it can only fit 21.7. So the correct answer is 21 inches long. We cannot round up, because if we round up, that tube won't fit in this box. All right, let's do another one together. Number 2. Tori ordered a replacement part for her desk. It was shipped in a box that was 4 by 4 by 14. What is the greatest length in whole inches that the part could have been? So we're going to draw, a box. All right, do your best. And it's going to be 4 by 4 by 14. And again, if it's going to fit in a box, it's going to go from the front to the back. It's going to cross over the dimensions from the front to the back. But if you're talking about a box that's going to cross over the front to the back, we can use the same equation. A squared plus B squared plus C squared equals L squared. So that would be your new equation. And I'm going to use my dimensions, just like I showed you here. So if you don't understand why I'm using these 3, go back and watch this one and just watch and listen and see if you can figure out why I'm using all 3 numbers. 16 plus 16 plus 196. And so I think 14 squared is 196. 228 is L squared, and I'm going to take the square root of both sides. So the square root of 228 is about 15.1, but again it says whole inches, and the biggest shape or the longest shape in whole inches would be 15 inches long, because anything over 15 inches wouldn't fit, or whole number, 16 inches wouldn't fit in this box. All right, number 3, a cube. So if you want to draw a cube, you start with a square. And then the way I draw 3-dimensional is I just go diagonal, diagonal, and then I go across, and then I go diagonal, and then I go down. So a cube has sides of 3, so 3, 3, and 3. We need 3 dimensions. So length, width, and height for a 3-dimensional shape. You need 3 sizes. Find the length of the diagonal. So again, the diagonal is going to go from the front corner to the back corner of the cube. And we can start with our equation. We fill in our dimensions. So 9 plus 9 plus 9. 27 equals L squared. We're going to take the square root of both sides, and the square root of 27 is approximately 5.2 centimeters, and it just says find the length so I would leave it. It doesn't say the whole number, it just says find the length. All right, so number 4 is a little bit different. Number 4 says a cone has a base diameter. So if you want to draw a cone, start with the top of a triangle, and then you're going to curve the base. And a cone has a base diameter of 10 centimeters. So I'm going to, diameter means we're going all the way across, 10 centimeters. Its height is 12 centimeters. So remember, height makes a right angle. What is the slant height? So over here we have our slant height because it's slanted. That should make sense. The slant height is slanted. It's not straight up and down. I'm just checking the time. Okay. Now, what is the slant height? Now, if you were to look at this for a cone, and I wish I had a cone to show you, I can sort of maybe make a cone. Well, this is not a good, okay, I can't make a cone. I wish I had something that was cone shaped. But if you had a cone and you were trying to find the slant height of the cone, it wouldn't actually go across the three-dimensional shape. It would just be the one side of the cone. So I've outlined the slant height. And again, we're not going across the cone. We're just going down the side of the cone. So we would use the Pythagorean Theorem like normal for a cone. We're not going across any kind of dimension jump. We're looking for the slant height, which would be the hypotenuse. So I have one leg is 12, and one leg, the diameter is 10, so half of it would be 5. And 144 plus 25 equals c squared. This is 169. Now, I know this is a Pythagorean triple, 5, 12, and 13, so the correct answer would be 13 centimeters is the slant height, 13 centimeters. And again, I got 5 because I only wanted half the diameter to make this right triangle. Okay, so you try, determine the length of the longest piece of timber which could be stored in a regular rectangular shed, 6 by 5 by 2. So if you had a rectangular shed, the longest piece of timber, so again, timber would go from the front corner to the back corner. What is the longest piece of timber that could fit? Pause it, you try this one, and then press play when you're ready. Okay, so this is actually going across from the front to the back, like from the front or the left to the right. So I would use my new equation. And, whoops, I forgot 2. So 2, 6, 5. So 6 squared plus 5 squared plus 2 squared. 36 plus 25 plus 4. 36 plus 25 plus 4. 65. And then I would take the square root of both sides. And does it say whole number? It does not. So the square root of 65 is going to be 8 point something. 8.06, so 8.1 meters high. Or 8.1 meters long. Okay. I hope you got that one right. Let's flip it over and do the back. Okay, so number 5, a can of drink is in the shape of a cylinder with height of 15 centimeters and a radius of 4 centimeters. What is the length of the longest straw that could fit inside the can? So it told us that the radius was 4, and we know that it is 15 centimeters tall, so we're looking for a straw. So now my question to you is, from the corners, in a can, would the straw be going across from the front to the back of the can, or would it just be going straight, like from one side to the other? And if I had a cylinder, I mean, I have my water bottle. All right, so this is kind of like a cylinder. So if I wanted to put the longest straw, I would put diagonal, but because this is a circle, it's not like there's really a front and a back. And so it would just be like the distance of the can using this right triangle that we've created. So put your right angle here. So this is just regular right triangle. And the legs, so we have 15 and then this leg all the way across is 8. Okay, we don't want to use 4 because my right triangle goes all the way across the diameter. And the problem, they gave us 4, but then we would need to see, oh, I need to use 8 because it goes all the way across. Let's see, 225 plus 64. Can you hear me typing on the calculator? Oh, 289, and I know that 289 is 17. So 17 centimeters would be the straw, and this was a Pythagorean triple. 15, 8, and 17. That's a Pythagorean triple. I should have known that. And again, we didn't have to do the long formula because it's not going, because it's a circle, so it's equidistance all the way around. All right, number 6, to the nearest tenth, what is the height of the square pyramid? Now, height is going to be in the middle of the square pyramid because it has to make, I know my line's not, it has to make the right degree angle. This is the slant height over here. And then we know that the side of the pyramid is 28.8 centimeters. So maybe you can see I'm going to create a right triangle. And I already know that this is the hypotenuse because the hypotenuse is always across from the right angle. In this particular example, in the pyramid, because I'm finding the height, I'm going straight up and down and I'm making a right triangle. I'm not going across from the front of the pyramid to the back of the pyramid. I'm just going straight down. So I would use just a regular right triangle. I'm looking for the height, so this is the leg. I already know the hypotenuse is 42.2. I'm looking for the leg, so I'm just going to call this A. Now, what would the length of this leg be? If the whole thing is 28.8, this would be 14.4. And then 14.4 squared, 207.36. Yes, I'm using my calculator. And then 42.2 squared, 1780.84. We would need to subtract from both sides. 1780.84 minus 207.36. And I'm left with 1573.48. I hope I'm doing my math correctly. You'd have to take the square root of both sides. And again, I'm going to the nearest tenth. So A is about square root 1573.48. So to the nearest tenth, I'm getting 39.66, so 39.7 centimeters would be the height of that pyramid. And it makes sense because the height would need to be a little bit less than the slant height, the hypotenuse. So 39.7 is less than 42.2. All right, the last one you try, I know this is long. The last one you try, find the height of the cone, round to nearest tenth of an inch. Now, in a cone, we've already done cones. It's not going to be from like the front corner to the back corner. It's just going to be the regular right triangle. So you try, pause it, and then you try. I always start with Pythagorean Theorem. Because I know this is my hypotenuse, that's going to be 15. I'm missing a leg, and then my other leg is 5. All right, square root of 200. It's my phone, if you can hear that. About 14.14, so 14.1 tenth of an inch, so 14.1 inches. All right, so I hope you got that right. All right, I know this is long, but we are going to practice more Pythagorean Theorem in 3-dimensional in class. All right, Control, Shift.